Okay, so I thought I would bring out the snowman since looks like we're going to be able to make one tomorrow. So anyway, we need to talk about standard deviation. And standard deviation is really about when you look at your data, how spread out those numbers are. Okay, so standard deviation is how spread out your data is. Okay. Oops, forgot your date. What's today? Today's 2/11/13. Oh, not 13. Oh, 14. Okay. So it's how spread out your data is. So when you calculate standard deviation, a low outcome tells you your data is close together. If you get a high answer, your data is very spread out. So sometimes that's good, sometimes that's bad, you know. So basically I'm going to show you how to calculate the standard deviation. If our number is low, that means all our data is sort of packed in together, you know, in a close range. But if our standard deviation number is really high, that means the data is spread out, you know, all across. So when you're doing standard deviation, the symbol for standard deviation looks like this. Okay, so that means we're finding standard deviation. It's very big. My little mouse thing's not working, so I'm having to do the drawing myself here. Okay, so there's kind of a long process to finding standard deviation. You have to find the mean, and then you have to subtract each number from the mean, and then find the difference and square it. Luckily, our calculators do that for us. So on our calculators, basically what we're going to do is we're going to turn the calculator on. You might want to write this down, these calculator steps. We go to second list. Okay, so we have second list. That's the blue words above the stat. We're going to go over to math. So you might write yourself a note, second list, and over to math, especially if you don't have a calculator. You want to have some notes for when you get to school, you can use one. And then you can see number 7 here is standard deviation. So we hit 7. So now we have the standard deviation. So what we want to do is we want to enter our data. Before we enter our data, we have to put a special parentheses. We have to put this fancy one. Or a bracket that's above the parenthesis. So we're going to do second parenthesis, and you can see you get this nice little squiggly one. Then we're going to put our data in commas. So we'll put in 1, and then here's your comma above the 7, 5, comma, let's see, 10. So you always want to check and make sure you got it in right before you finish. So I'm going to check each one of these numbers, make sure I have it right. Okay, so then we're going to we have to end the fancy parentheses, the squiggly one, and then I have to end the regular one. So we have bracket parentheses, okay? And then we're just going to hit enter. And so the standard deviation of this is 8.16 for blah, blah, blah. All right, so that's fairly spread out. A close one would be around 1. So you can see it goes from 1 to 24, so that is a good spread. So then we would say the standard deviation here is, I think it was 8.16 if we were just rounding. Okay, so that would tell you that, that your data is quite spread out. Okay, so I want you to try this one on your own and find the standard deviation. Okay. And then you'll also have things like this. Well, they'll want you to find the standard deviation given a box plot. So you might want to think about that for a second. How could I use that and get standard deviation? Well, if we go back to our calculator, the box plot tells you how many of those numbers that you have, right? So I have a 0, I have a 2, I have 2 5s, a 6, an 8, a 10, and a 12. All right, so very simply, I'm going to go to my second list again, go over to math, down to 7, put in my special bracket here, and then put in my numbers. I have a 0, 1 0, comma, I have a 2, I have a 5, and I have 2 x's, so I have another 5. I have a 6, I have an 8, I have a 10, and I have a 12. Make sure I got, yeah. Okay, so I'm going to go through and run through that again. 0, 2, 2 5, 6, 8, 10, and 12. And then we got to end the bracket and end the parenthesis. And then we hit enter, and the standard deviation here is 3.96. So that's a little bit closer to 1. So we can say this data is a little more closely compact than the data up there. Okay, because here you have one way down here, one, and then they're really kind of spread out, where these are a little bit more close together. They're between 0 and 12. Okay, so I would like for you to calculate standard deviation on this one on your own. Now, if you don't have a calculator, perhaps you could just write out what it would look like on your calculator, and then when you get to school, you could put it in. So you could put STDEV, parentheses, fancy parentheses, list the numbers you're going to use, and then leave it at that. And then when you get to school, you could do it if you don't have a calculator at home. So you're going to do this example here on your own and this example here on your own. And then I also want you to write a sentence about how closely spread that data is. So here we would say, you know, since it's an 8, the data is spread out. It has a higher standard deviation. Okay. Down here, we would say, you know, it's not super close, but it's obviously better than the one above. So we would say that standard deviation is, you know, maybe fairly close together. I know that's off. Okay, and then a lot of times on your test, it'll give you 2 standard deviations and ask you to find the difference between the 2. So obviously we just subtract those. Okay, so make sure you have notes on what standard deviation is, how you calculate in your calculator, and do these 2 practice problems here. And I don't know if I'll see you tomorrow. I know you'll miss me. But make sure you have that and that you're ready for your test when you do get back from school, and that your Winter Olympics activity is finished as well. Good night.